All right. Welcome back, students. And I want to talk about this last part, which I believe is quite important, given that we are dealing with a topic that has got a lot of practical applications in this country, whereby this country is an agricultural country. Yeah? So most of the people, especially in the rural areas, they just throw away waste, and it's something which you as an engineer can take advantage of to try to harvest biogas out of the waste that is being thrown. So I'm just giving some practical skills from my many years in dealing with the biogas production, especially from a scientific point of view. So I'm just giving some practical suggestions. Now, some of these things, they are not in the notes, so I think in this case, this video series is quite important. The choice of organic waste matters. Okay, just look at this table. I think you can be able to look at it here. Fats and oils, they produce a lot of biogas. I think you can be able to see here. They can produce up to 1,200 cubic meters of biogas per ton of waste. You're talking about ton, you're talking about 1,000 kilogram of waste. So you can get about up to 1,200 cubic meters, yeah, of biogas. The problem about fats and oils, as much as they can produce a lot of biogas, they are quite sticky. This is my experience. Yes, you are going to get a lot of waste, but these are things which can produce a lot of sludge, and they produce they bring a lot of problems with the stirring, because you can know about fats and oils, the way they can stick to a mechanical system, and if you do not digest, they are going to really float on the top, and the bacteria which are in the aqueous phase may not be able to mix with the oils which are floating on top. So they're going to produce a lot of biogas, but they bring in issues. So you need to make a trade-off here. Bakery waste, you're talking about bread and other things, they produce up to around 600, about 700 cubic meters per ton of waste. Food scrap, you're talking about the normal waste, not much. I also need to put in the potato waste at around close to 300 cubic meters. Excuse me, per ton of waste. As you can see, greens, almost 200. That's going to surprise you that if you are going to set up a biogas digester just to digest things such as the waste like cow manure, pig waste, and chicken manure, you are wasting a lot of I don't know what they can say wasting, but you're not getting value for money. This is not where you may need to do something called cold digestion, whereby if you've got a lot of cow manure, pig manure, and probably chicken manure, you may need to mix it with some of the wastes, green and other things that produce more waste to be able to increase the biogas yield. Yeah. Okay. Now, I need to mention something that you as an aspiring engineer or as an engineer in training, you should be able you can be able to make biogas from the waste that is normally thrown away. For a start, you could just try to make use of a container such as this one, which is from a water bottle. These things are just thrown away, but you can be able to make holes For example, I've just put a way in which, okay, I've not put it down well, but you can be able to find ways of collecting the biogas through a system such as this one, and there are pipes in which you can be able to tap in the gas to collect it, and the gas can also be collected in for you to start with something like a car tube. Yeah, you can be able to tap in the gas. I'm giving you practical skills. You can find ways of collecting biogas through a system which will not release the biogas into the environment. Because as you know, biogas has got something like a small concentration of hydrogen sulfide, but that hydrogen sulfide, if it leaks into the environment, your neighbors are going to complain because of that. It has a smell of rotten gas. Yeah. So there are ways in which you can be able to remove the hydrogen sulfide chemical means, which I think I would let you do the research on that one, but something like sodium hydroxide or potassium permanganate or whatever can be able to really remove that one. And if you want to use the biogas for something like for example, like a portable generator, then you also need to remove the carbon dioxide and be left with pure methane. So you can be able to bubble the biogas through something like sodium hydroxide or potassium hydroxide, sodium hydroxide. All those kind of things are going to absorb, are going to convert carbon dioxide in the biogas into something like a carbonate. For example, potassium carbonate, sodium carbonate, and you're going to be left with pure methane. All that I need to emphasize is ensure once you've removed carbon dioxide, excuse me, the methane can be very explosive. So you need to ensure that you need to be working in a well-ventilated area and you do not produce a lot of pure methane, because you can do what? You can get injured, or you can easily die because you're dealing with a very explosive gas. So that's something that I need to mention. For me, I would rather advise you as a consultant in this area to leave the production of pure methane for engines to experts, so that you're not going to be destroyed. Please remember, pure methane is very explosive and it can lead to death. Yeah, try to avoid that one. Leave that one to experts, but you can use the removal once you've removed the what you call the hydrogen sulfide, which tastes like the rotten eggs. The mixture of the methane and the biogas can be used for cooking safely. Yeah, so that's what I'm actually emphasizing on. Don't go to the removal of the carbon dioxide, because that will make that will cause that will bring safety issues. Please avoid removing the carbon dioxide. Is that okay? Yeah. So okay. So how can you store biogas, especially on large scale? Yeah? The best way is to bubble the biogas through what? If you've got your pipe which is bringing in the biogas, you can have a container containing water, and then that one is in a what? It's in another container. Okay, so in this case, the container which you want to store the biogas contains water, and it's in another, and it's inverted upside down, and this one is in a big basin also containing water. This will avoid any leakage. So as the biogas is coming in pressurized, the biogas that is produced is produced under pressure. Once it comes into the container which contains water, the gas as it comes in is going to displace the water. So the biogas is going to collect here, and the water is going to bubble out. So this biogas is going to be trapped, and it's not going to leak out. Yeah, and then you're going to have a tap which you can only open to be able to release the biogas into the system. So this is an easy way of collecting biogas on a relatively large scale. But I think I'll leave it upon your imagination to really find out practical ways of how to scale up your digester, and also how to actually store it. Yeah. But the point which I'm trying to dive at is that you can be able to make biogas out of the waste that is currently being thrown, especially if you are living near a market area. But something which I may need to mention, and this thing is from a practical point of view, to really start up a biogas digester, you may need to, the source of the bacteria is called an inoculant. So in this case, you may need permission from the ones managing the slaughterhouse to be able to be allowed to get the contents of the ruminant stomach. Yeah, it contains a high concentration of the bacteria, which is for starting the anaerobic digestion, as opposed to waiting for about a week or two before the bacteria has actually multiplied. Yeah, so that one can really quicken the starting of the bacteria, of the anaerobic digestion. But I'll leave it upon your imagination to really come up with a practical digester that can work in your environment. So once again, the lecture notes on the anaerobic digestion are quite detailed, and I would like you to go through it. And if there be anything that is not easy to understand, please remember my email, jmwaniki as one word. The other one is at uonbi.ac.ke, and through your class reps you can get to me via WhatsApp, and I will be able to respond to any question that you may have regarding the anaerobic digestion and any other topic that you've actually covered. Thank you very much. Okay.